Okay, now we are going to talk about specialized counting studies, and whatever we have talked about earlier and the difference between them is in specialized counting studies we are basically focusing on areas. So we are trying to find out how much traffic goes out and into the area. Okay, so there are three types of specialized counting studies that we will discuss, but there are others as well, and these are origin and destination counts, Cordon counts, and Screenline counts. Let us start with origin and destination counts or origin destination studies. Origin destination means that you are trying to find out the origin of the trip and the destination of the trip, the starting zone of the trip and the ending zone of the trip. Okay, so we are not looking for the specific address, but we are looking for from which zone of the area the trip or the traveler came out and which zone in the end he went into. Now origin destination counts can be done in three ways. So you can see the three different methods here: license plate, postcard, interview. In license plate studies, you place observers on the entry and exit points of the area, and these observers are recording the license plate numbers of the vehicles. When they come out, when they come out from the field into the office, then they will sit together and then they will match the license plate numbers which they have recorded. So, for example, observer 1 recorded license plate number, for example, XY123 coming out of area 1. Okay, and this is the area from which anybody has recorded this vehicle coming out. Nobody else has recorded this vehicle to come out from any other area. So this becomes the origin. Then another observer who was in, let's say, area 4, at the entry of area 4, he says, I saw the same vehicle going into area 4, and then there is no other person who has seen this license plate number to go into any other area. So in that case, it came out of area 1, went into area 4. So area 1 becomes the origin and area 4 becomes the destination. Okay, this is how license plate number technique works, and this is similar to what we have discussed in the license plate method for travel time observation. It was along the same methodology. Then we have the postcard studies. In postcard studies, you develop a very small questionnaire card, and in that questionnaire card, one side has the address and the other side has some questions. Two questions obviously are: what is the origin of your trip, what is the destination of your trip. Okay, and these cards are distributed to the drivers and travelers who are traveling within your study area. Okay, so these drivers and passengers will take your cards and they will go with it. Okay, so you can distribute them in parking places or at signals or wherever you find it is convenient for you to distribute these cards. So the people who will take your cards, they will fill it out, they will answer the questions, and then they will send it back to you through post. So your address is mentioned on the card. Okay, so that's why we call them postcard technique. Before WhatsApp and all these channels came up, this used to be the way of greeting, Eid and happy birthdays and so on and so forth, the postcards. So you can still use it for traffic studies. We are still backward in that case. Okay, then we have interview studies. So you go to people's houses and you interview them. So you go to different houses in the zones which you have made, and then you ask them what is the origin, destination, travel time, how do you travel, and so on and so forth. Interview studies are generally longer and they have more questions, so you can use the data in some other studies as well. Now, no matter which type of technique you apply, license plate, postcard, or interview, you cannot collect data for each and every person. License plate technique, you are recording the data, so while you record one number, other vehicles will move. Postcard, it is not a guarantee that everybody will return your postcard and they will fill it. Interview studies, it takes a very long procedure to interview even one family, so it is not possible for any interview to collect the data for all of them. So whatever method you apply, you will have a sample of the actual origin destination counts. Okay, so then we need to calibrate or expand this sample to give you the actual count. So for that we do traffic studies as well. So on the entry and exit points of your area, you have the observers, and these observers are just counting vehicles which enter the area and leave the area. So in the end, you have a sample of people with a pair of origin destination, which zone they came up and in which zone they entered in the end. And then you have traffic counts at total number of vehicles entering a zone and leaving a zone. Okay. So the sample which you take can be shown with this matrix you can see here. So for example 50, their origin was zone 1, their destination was also zone 1. So we call it intrazonal. This type of a trip is known as intrazonal, INTRA, intrazonal. And then for this 8 represents people who came out of zone 2 and then went into zone 1. Okay, so this is a sample you got from any of these techniques, and then you did a volume study like counting vehicles entering the area, leaving the area, total number of vehicles entering area 1 250, entering area 2 310, and so on, total number of vehicles coming out of area 1 210, for area 2 200, and so on. Now when you do the summation of each row, so when you do the summation of the first row, this is total number of people who in your survey said they went into area 1. So this summation should match with the volume count you have. Now the summation is 95 because obviously, as I said, it's just a sample, but the actual number should have been 250. So now I have to come up with a method to make this 95 close to 250. Okay, and same thing with the column as well. The summation of people who said they came out of area 1 is 88, and the actual number of vehicles which went into area 1 is 210. So somehow I need to make this 88 equal to 210 or close to 210, and this method is known as the calibration of the origin destination matrix. Okay, and so the volume from the field is more accurate because it's not a sample, it's actual count. So I need to change this matrix to make the summation close to the volumes which you got from the field. Okay, so what we will do is, first of all, we will calculate a ratio for each column, and for each row we will calculate ratio. This ratio will be volume upon the summation which you got from the matrix. So the factor for row 1 will be 250 upon 95. The factor for column 1 will be 210 upon 88. So for each row and column you will have a factor. Okay, then each number in the matrix will be multiplied by the average of the factor for the row and column in which that number is. So for example 50 is in first row and first column. Okay, so 50 will be multiplied by the average of the factor which you will get after taking the ratio of these two numbers and these two numbers. Okay, and if you want to see the equation, then equation is over here. This is the equation I'm talking about. So trips which you already have, factor for the row, factor for the column. Okay, or factor for the column, factor for the row. Okay, so and each factor means, like I said, volume upon the summation. So T represents the number which you have in the matrix. Okay, so if you apply this, then let us see what happens. Okay, so this is the initial, and then we have calculated the factor. Okay, so 250 upon 95 gives you 2.63. 300 upon 106, 2.92. Similarly, 210 upon 88, 2.39. 200 upon 99, 2.02, and so on. Okay, now if you want to change, then for example for this 50, if we multiply with the average of 2.39 and 2.63, okay, like this. See here, this, you do this. So now the new number for the new matrix for the next trial is 125. So you see this number is 125. Okay, now if you want to change this number, so second column, first row, this number is actually 8. Okay, so what I will do is, so 8 will be multiplied by the factor of the second column, which is 2.02, plus the factor for the first row, 2.63, because this is the second row column, first row, so 2.63. Okay, and this should give you 19. Okay, my calculations are correct, this should give you 19. Okay, and this is what you can see here. Okay, so now the whole matrix will change in this manner. The whole matrix will change in this manner. Okay, each number will multiply by the average of the row and column. Now once you have done that, you will calculate new summations. So each row will have a new summation, each column will have a new summation, and then you will recalculate the factors as well. the volume will remain the same. Now you divide the volume with the new summation you have. So 250 upon 267 gives you 0.94. Okay. 210 upon 232 gives you 0.9. So 210 was the volume which you originally have, and then 232 is the new summation which you have after changing the matrix. Now what is the rule here? You can see none of these numbers is exactly 1. Okay. Our ideal situation is that these numbers become 1. All these factors now become 1. Volume becomes exactly equal to the number of trips you have in the matrix. But it will take a very long process to have exactly 1 for each row and column. Okay, so we have established a very convenient range. Range is between 0.9 and 1.1, which means a difference of plus minus 10% is is acceptable. So we want to have 1. So minus 10% means 0.9, plus 10% means 1.1. If all these ratios are between 0.9 and 1.1, then you can stop there. These numbers in the matrix, and then they will be considered as acceptable. But you can see that some of these numbers are they are out of the range. For example, this number for destination 3, and for example this number for origin 2 and destination origin 4 as well. So I have to repeat this process at least one more time, so these numbers come in the range. Okay, so now I have a new matrix, I have new factors. I repeat the same process with the new matrix and the new factors. So for example, I want to change now 125, factor is 0.94 and 0.9. Okay, so 125 and then 125 multiplied by 0.94 plus 0.9, and then you are taking the average. Okay, so this will give you 116. Okay, and same thing with all the numbers. Okay, like we had done previously, and then the entire matrix will change, new summations will come, and then you will recalculate the ratios. Again, volumes are the same which you have from the field. Okay, volumes are not changing. So the new ratios, again the same limit will be applied. These ratios should now be between 0.9 and 1.1. So all destinations are in the range. If you look at the origins, then you can see the one number is still out of the range. Okay, now with each trial, with each iteration, these numbers are becoming closer and closer to 1. If you look at these numbers, okay, so earlier I had one destination and 2 origins which were out of the range. Now all destinations are in the range and only one origin is out of the range. Okay, and even the numbers which were in the range, they are now closer to 1. So earlier for the first row the factor was 0.94, now it is 0.97. So even the factors, all factors are becoming closer to 1, whether they were in the range or out of the range. So with each iteration all numbers are becoming closer to 1. If they are not, that means you made a mistake in the calculation. This is like a check. Okay, so if there is no problem with your calculation, the numbers with each iteration, the factors should be getting closer to 1. Okay, so in this case I have to perform one more iteration, okay, with the new factors and so on, and then these are the new numbers and the new summations and new factors, and you can see now all of them are in the range. Okay, so this is origin destination count. Then the second specialized counting study is cordon count. Cordon means a boundary. So you have 2 areas, and sorry, not 2 areas, you have an area, and along this area establish a boundary. Establishing a boundary means that may not be a physical boundary. Like you don't have to place a barrier around the area. Then how will people come in and go out? Okay, so it's like a thematic imaginary boundary which you will establish on the map, and whoever crosses that boundary, you are interested in that person, that traveler. So how many people cross the boundary, coming in or going out? This is the purpose of having the cordon count. Why we do cordon count? The application is that some areas attract more traffic, and we want to plan these areas in a suitable manner for all the travelers. Okay, there are some commercial areas. For example, the diplomatic area in Bahrain, and then you have the financial the financial harbor in Bahrain. So these areas attract a lot of traffic. Okay, and then we want to plan this area, that we have enough parking spaces, that we have bus routes in that area, because so many people are using it. So in order to do this planning, I must know how many people are gathering in that area at a time, how much space I need, how many vehicles enter the area, how many travelers come in this area at a particular time. So basically accumulation of vehicles or accumulation of travelers in the area is to be found using a cordon count, so I can plan for all of them together. Okay, so I want to plan for this particular area which is attracting a lot of traffic, and around this area I establish a cordon. Now there are some rules when you are establishing a cordon. Okay, how large or how small should be this boundary. So you are establishing the boundary, it's an imaginary boundary. So this boundary should be large enough to include all the activities which are part and parcel of that area. Okay, if you are talking about financial harbor, then or let's say diplomatic area, then you should make a boundary which at least includes all the office buildings you have in that area. It should be large enough. Sometimes we focus too much, that the mistake can be you focus too much on a specific building or on a specific facility which is major in that area, but there are other facilities as well which are similar to that and they are in the close proximity, and you ignore them. Then your planning will not be effective, because you are just focusing on a particular type of traveler, okay, or particular business. Okay, so remember, we are talking about area. One business can dominate, but still other businesses are also contributing, so all these activities must be included. Okay, then so this is how large it should be. Then it should be small enough to not include different land uses. Okay, make sure that your boundary does not include various land uses, because again the planning will be very difficult for you then. Okay, so you have a commercial and residential area which you have included in the same boundary, then both these types of land uses have their own traffic patterns, traffic type of vehicles, and the timing of the vehicles which are coming towards a residential area is not the same as a commercial area. So because of that, you cannot plan effectively for both these land uses at the same time simultaneously. So in one particular zone, within one particular cordon, I'm trying to focus on one specific land use. Okay, so don't make it too large that various land uses are included, and don't make it too small that even for that land use you are not including all the possible facilities in the same area. Okay, make sure that your boundary crosses the streets and highways at mid-block locations. Don't make the boundary crossing at the intersection, because at the intersection turnings are possible. So you will not be sure whether the vehicle left the area or entered the area, because it may take a right turn and then come back into the area. Okay, it may take a U-turn, so your problem will be complicated. So if you make a boundary which is crossing at the mid-block locations, for example like this, okay, so the roads are crossing like this, right? So this is a road, okay, and the intersection is somewhere here. So I know for vehicle can just come in and go out. There is no turning here. Okay, so make sure that the boundary crosses at the mid-block locations. And another thing is, if you have a physical boundary available around the area, make like a physical object around the area which is blocking the travel of the vehicles. Make that object part of your boundary. For example, a river. So obviously vehicles cannot cross from any point of the river. Okay, so it has to be a bridge. So for example, this is the river, okay, and this is your entire area. Okay, so make your boundary or make river part of the boundary. So in this entire region where you have the river, the crossing point is only this bridge. So in this entire boundary, along this entire part of the boundary, you have only one observation point. Similarly, you can have a highway as well, okay, a very high speed highway from which people can only enter from a ramp. Then in that case, only that ramp will be your observation point. Okay, so whatever object you have, make or a railroad. Okay, so you cannot cross a railroad from any point. So So if you have any physical objects which are going around your area, make your boundary along this object, so your observation points will be minimized. Okay, there's only 1 or 2 points from which this object can be crossed, and your observation points will only be that. Okay, now let me explain how these studies are done. Okay, first of all, you go to the site, you have the area, and before any activity starts in that area, you go there and you take the count of vehicles which are already in that area. They may be parked on the streets, they may be delivery trucks or anything which are already inside the area. So remember, activities in that area have not started, shops have not opened, offices have not started, schools have not started, whatever type of activity is happening in that area. Because of that, the traffic has not started to move, or you may have 1 or 2, 3, 4 vehicles exceptional. It's not a problem, but you start earlier than the normal activity time in that area. So for example, you see they have started at 4. So between 4 and 5 a.m. what they were doing, they were just counting vehicles which are already parked in the area. So these are 250 vehicles. Then between 5 to 6 a.m. now this is where the counting begins. Counting of vehicles entering, vehicles leaving. So like I mentioned, for travel time studies and then for origin destination counts, you have observers which are counting vehicles entering and leaving the area. So at all the possible entrance and exit points, you place observers. Okay, and these observers are counting. So obviously from 5 a.m. according to them the activities have started. So 100 vehicles entered in this 1 hour, 20 left. Okay, 250 were already in the area, 100 more entered and 20 left. So how many are in the area? 250 plus 100 who entered plus 20 who left. So 330. 250 plus 100, 350 minus 20 is 330 vehicles are now in the area. Okay, so you must have a parking capacity of 330. Then 6 to 7, 150 vehicles entered, 40 left. So 330 plus 150, 330 is the previous count, plus 150 who entered minus 40 who left. So now the new count of vehicle accumulated is 450. Similarly, you see now we do this for every hour. I see the vehicle count is increasing, and then from noon onwards the vehicle count starts to decrease, because this is when the people are now leaving more and entering less. So the count has started to reduce. So it's like a office area or something like that, where people come in the morning and the evening or afternoon they start leaving, or people who are come for their business they start leaving, and so on. So the maximum capacity you need on the streets of that area is this much, 1180. Okay, the maximum accumulation is 1180, and then it starts to die down, and you can see the last count at which you stopped your study. Okay, so this 5 p.m. this is 5 a.m. Okay, so you did not do it for 24 hours. It's actually 13 hours. Started at 4 a.m. finished at 5 p.m. This 13 hours. Okay, but before 5 p.m. most of the activities in that area are finished. Whatever schools or shops, whatever there was, they have finished their business. They have closed. So you see the final count is very close to the initial count. Okay, this is another indication that you selected the study period appropriately. Okay, that the final and initial count should be close to each other. They cannot be exactly the same, but they should be close to each other, and then you should be able to see this trend as well. They increase and it started to decrease as well. Okay, so it is showing that you covered all the demand, the time during which the demand was very high. You covered all that time. Okay, so this type of trend should be shown. Okay, and if you plot it with respect to time, then it should be like this, goes up and down. Now you can see we have two lines, one for all vehicles, one for automobiles, and then we have another line for trucks. Now in accumulation count, so we call it the accumulation count. Cordon count is also known as accumulation count, because you are counting vehicles or trying to estimate the number of vehicles which are accumulated in the area. We call it accumulation count as well. So in accumulation counts or Cordon counts, you may count vehicles with a combined observation, or you may have separate counts for different types of vehicles. It depends upon what is your point of concern for the traffic demand in that area. There are certain areas where specific vehicles are more affecting the planning. For example, school areas. Then buses affect the planning more than other facilities, other types of vehicles. So buses should be counted separately. So we should know their timing, their accumulation time, and their peak demand time. In port areas, for example, industrial areas, trucks may have this importance. Okay, so trucks should be counted separately, but it depends upon you. If your area is not of this scenario, it's not of this nature, then just take the total count. Or in some cases, cars should be counted separately, because cars are having the peak demand, or they affect the traffic in that area more than any other type of vehicle. Okay, this is, I would say, the bad example, although this is a project which we did in Bahrain. Okay, this is for the accumulation for diplomatic area we did in 2018. You can see it started at 9, started before 8, so this is fine. Started before the offices were open, and then you have the accumulation of 48 vehicles. But 8 to 9, then they went up to 12, so you can see the count is increasing, and then they said, okay, fine, we will not do it after this. Okay, so you can see they did not cover the full trend. They did not cover the trend when the accumulation is supposed to go down. Okay, so this should not be the case. Okay, but it's a real data, so I thought that I should show it to you. Okay, one way of representing the accumulation count is showing the crossings. So you have the imaginary boundary, which is shown by the dotted line, and you can see this dotted line crossing many roads and streets. The streets which are with thick lines, bold lines, they are major highways, so you can see they are two-way, so people can enter and leave from these. And then we have thin lines, gray lines basically, which are only one-way streets. So these are small streets, so you can see only one-way movement on these streets. But then so this crossing representation is basically telling you from which highway people were coming out and going in, and what was the number. Okay, and then you can see that it was, this complete count was taken in 24 hours. Okay, total entering vehicles, so you add all the numbers which entered, 16,935 in 24 hours, and the people who left, 15,638. So almost equal, right? Almost equal. Okay, so number of vehicles which were left at the end of the day are 1267. Okay, so entering and leaving both are almost equal. Okay, a difference of around 1,000 in a day is not much significant. Okay, then we come to the third type of specialized counting strategies, which is screen line. A screen line is a sort of a barrier. Okay, it's like a barrier, a boundary between two mediums or two zones, two areas. So windows have screen lines as well, but they are separating the inside with the from the outside. So a screen line count, in a screen line count between two areas, you put an imaginary line. You put an imaginary line or a boundary. And then you count traffic which is moving between the two areas. Counting basically traffic moving between the two areas. So a screen line is like a smaller version of origin destination counts. In origin destination counts, you can have any number of zones, 2, 3, 4, 5, 6. Screen line counts only 2 zones. So it's an origin destination study between 2 zones. Okay, and again you are making the zone with the screen line, imaginary screen line, and this is screen line. Again we have the guideline here that if between the two areas you have a natural or a physical barrier like a river or a railroad or a limited access highway, a high speed road, from which the observation points can be minimized, then you make this part of the screen line. Okay, and I will show you in this slide. You can see here. So these are the two areas. Between the two areas I have a river. So this river is made a part of the screen line. So screen line is whatever goes along the river. So along the river I have just few crossing points. Okay, so my observation points are only the points from where you can cross the river. Okay, so this is an example here. And like I said, you can follow the same procedure which you have followed for origin destination counts. You take a sample using interview studies or postcard or license plate for the zone to zone trips, and then you do the counting as well, and in the end you have a 2 by 2 matrix between the two zones, a small 2 by 2 matrix between the two zones, and then you can do the calibration. Okay, so the procedure is the same. Now in a screenline count you can have different type of counts. You can have the external crossings, people who come from another area, so they are not part of this zone or this zone, but they are just crossing. So these are known as external crossings. So when you do the interview studies, then you know the percentage of people who did the external crossing. And then you have the overall count which you took from the field, so it includes internal as well as external. And then you have the internal crossings which will be somewhere between them. The total will include internal and external both. External crossing should be very low. If it is very high, that means you did not select the zone and the screen line properly, okay, or your study is not valid. Most of the traffic in these two areas are from outside, and then you are selecting or trying to plan using these two areas. Your study is not valid. Okay, so this depends upon how you select the two zones. Okay, a practical example of a screen line count is between Saudi Arabia and Bahrain. So the two zones are, let's say, the Khobar Dammam area and Bahrain. Bahrain is, we cannot say, we cannot specify the area within Bahrain. Whole Bahrain is like, two cities of Saudi Arabia. So two zones are Bahrain and so the Khobar Dammam area of Saudi Arabia. Between them, the screen line is the sea. Remember, screen line is a barrier. So what is the barrier between the two zones? The sea. Okay, and the observation point is King Fahd Causeway. The observation point is King Fahd Causeway. And if you want to see the screen line counts for this particular case, you go to King Fahd Causeway Authority website. They are all available there. Okay, so this is a good thing. And I have just downloaded two graphs from there. How many people enter from Saudi side? How many people enter from Bahrain side? And this is only for 1 month, and they have it for like all the months till from the time the highway the causeway was opened. Okay, so this is like a real example of a screen line count.